Stars, planets and the moons are not just the only part of the sky we see. In deep space, there are things that we can never even imagine. From rectangular galaxy to aliens, lost mass of the universe to lost lithium, to dark matter and dark energy, these are the top 10 most mysterious things in the universe that are still unsolved. If you are new to our channel, then please subscribe and press the bell icon so that you become a part of our notification squad. Number 10. The Fermi Bubbles. No, this is not a rare digestive disorder. The bubbles are massive, mysterious structures that emanate from the Milky Way's center, and extend roughly 20,000 light-years above and below the galactic plane. The strange phenomena, first discovered in 2010, is made up of super high-energy gamma-ray and X-ray emissions, invisible to the naked eye. Scientists have hypothesized that the gamma rays might be shock waves from stars being consumed by the massive black hole at the center of the galaxy. Number 9. Rectangular galaxies. Earlier this year, astronomers spotted a celestial body roughly 70 million light-years away, with an appearance that is unique in our visible universe. The galaxy Leda 074886 is shaped more or less like a rectangle. While most galaxies are shaped like disks, three-dimensional ellipses or irregular blobs, this one seems to have a regular rectangle or diamond-shaped appearance. Some have speculated that the shape results from the collision of two spiral-shaped galaxies, but no one knows for now. Number 8. The Moon's magnetic field. One of the Moon's greatest mysteries is why only some parts of the crust seem to have a magnetic field, has intrigued astronomers for decades, even inspiring the buried mythical monolith in the novel and film 2001: A Space Odyssey. But some scientists finally think they may have an explanation. After using a computer model to analyze the Moon's crust, researchers believe the magnetism may be a relic of a 120-mile-wide asteroid that collided with the Moon's southern pole about 4.5 billion years ago, scattering magnetic material. Others, though, believe the magnetic field may be related to other smaller, more recent impacts. Number 7. Why do pulsars pulse? Pulsars are distant, rapidly spinning neutron stars that emit a beam of electromagnetic radiation at regular intervals, like a rotating lighthouse beam sweeping over a shoreline. Although the first one was discovered in 1967, scientists have for decades struggled to understand what causes these stars to pulse, and, for that matter, what causes pulsars to occasionally stop pulsing. In 2008, though, when one pulsar suddenly shut off for 580 days, scientists' observations allowed them to determine that the on and off periods are somehow related to magnetic current slowing down the star's spin. Astronomers are still at work trying to understand why these magnetic currents fluctuate in the first place. Number 6. What is dark matter? Astrophysicists are currently trying to observe the effects of dark energy, which accounts for some 70% of the universe. But it's not the only dark stuff in the cosmos. Roughly 25% of it is made up of an entirely separate material called dark matter. Completely invisible to telescopes and the human eye, it neither emits nor absorbs visible light, or any form of electromagnetic radiation, but its gravitational effect is evident in the motions of galaxy clusters and individual stars. Although dark matter has proven extremely difficult to study, many scientists speculate that it might be composed of subatomic particles that are fundamentally different from those that create the matter we see around us. Number 5. Galactic recycling. In recent years, astronomers have noticed that galaxies form new stars at a rate that would seem to consume more matter than they actually have inside them. The Milky Way, for example, appears to turn about one sun's worth of dust and gas into new stars every year, but it does not have enough spare matter to keep this up long-term. A new study of distant galaxies might provide the answer, as astronomers noticed gas that had been expelled by the galaxies flowing back into the center. If the galaxies recycle this gas to produce new stars, it might be a piece of the puzzle in solving the question of the missing raw matter. Number 4. Where is all the lithium? Models of the Big Bang indicate that the element lithium should be abundant throughout the universe. The mystery, in this case, is pretty straightforward. It does not. Observations of ancient stars, formed from material most similar to that produced by the Big Bang, reveal amounts of lithium 2 to 3 times lower than predicted by the theoretical models. New research indicates that some of this lithium may be mixed into the center of stars, out of view of our telescopes, while theorists suggest that actions, hypothetical subatomic particles, may have absorbed protons and reduced the amount of lithium created in the period just after the Big Bang. Number 3. Is there anybody out there? In 1961, astrophysicist Frank Drake devised a highly controversial equation, by multiplying together a series of terms relating to the probability of extraterrestrial life in terms of the rate of star formation in the universe, the fraction of stars with planets, the fraction of planets with conditions suitable for life. He surmised that the existence of intelligent life on other planets is extremely likely. One problem, Roswell conspiracy theorists notwithstanding, we have not heard from any aliens to date. Recent discoveries of distant planets that could theoretically harbor life, though, have raised hopes that we might detect extraterrestrials if we just keep looking. Number 2. How will the universe end? We now believe the universe started with the Big Bang. But how will it end? Based on a number of factors, theorists conclude that the fate of the universe could take one of several wildly different forms. If the amount of dark energy is not enough to resist the compressing force of gravity, the entire universe could collapse into a singular point, a mirror image of the Big Bang, known as the Big Crunch. Recent findings, though, indicate a Big Crunch is less likely than a Big Chill, in which dark energy forces the universe into a slow, gradual expansion and all that remains are burned-out stars and dead planets, hovering at temperatures barely above absolute zero. If enough dark energy is present to overwhelm all other forces, a Big Rip scenario could occur, in which all galaxies, stars and even atoms are torn apart. Number 1. Across the multiverse. Theoretical physicists speculate that our universe may not be the only one of its kind. The idea is that our universe exists within a bubble, and multiple alternative universes are contained within their own distinct bubbles. In these other universes, the physical constants, and even the laws of physics, may differ drastically. Despite the theory's resemblance to science fiction, astronomers are now looking for physical evidence like disc-shaped patterns in the cosmic background radiation left over from the Big Bang, which could indicate collisions with other universes.